Okay, so today we're diving into C-sharp method keywords, but forget just thinking about syntax. We're going to be unlocking the secret tools baked right into C-sharp that let you write code that's faster, cleaner, and just plain smarter. These aren't just keywords, they're your coding superpowers.
Seriously, I want you to think of each keyword like a unique superpower. Knowing when to use virtual versus when to use sealed, that's what really separates a good developer from a great one. So let's gear up and explore these powers together. All right, first up, let's talk about what I like to call the flexibility force. These are the keywords that give your code its shape, its architecture, and its incredible ability to adapt and change over time. This is all about polymorphism and control. First up is virtual. Now, think of this like a really friendly invitation. When you mark a method as virtual, you're basically broadcasting to any other class that might inherit from this one, hey, here's how I do things by default. But you know what? Feel free to jump in and provide your own version if you think you can do it better. A classic example you'll see everywhere is an animal class. It's got a virtual speak method. A dog, a cat, a bird, they all speak, but they all do it very differently, right? Virtual is what lets them each have their own unique sound. Now, is there a catch? Kinda. There's a tiny performance hit from something called a V-table lookup, but for 99% of apps, you'll never even notice it. So, if virtual is the invitation, what's the response? Well, that's override. It's you RSVPing with a big, yes, I love to. You use this keyword to provide that custom logic for an inherited method. You are officially taking control and tailoring the behavior. So picture this. You've got a generic vehicle class. A car class that inherits from it can then override the drive method to define exactly how a car drives. You know, with four wheels on the pavement, completely different from how a plane might drive. Okay, now let's switch gears to abstract. If virtual was a friendly suggestion, abstract is, well, it's a hard and fast rule. It's a contract. When you make a method abstract, you're defining what it's called, but you provide absolutely zero implementation. You're forcing any subclass to provide its own version. There's no default to lean on. You have to do the work. And on the complete opposite end of that spectrum, we have sealed. This is your power to just say, nope, we're done here. The customization ends with me. When you seal a method or even a whole class, you are locking it down. It's final. No more changes allowed. And this all sets up a really interesting duel, right? On one side, you've got virtual, giving you all this amazing flexibility, but with that little bit of V-table overhead. On the other side, you've got sealed, which gives you rock-solid stability and a nice performance boost because the compiler knows it can optimize the call directly. It's the ultimate showdown between flexibility and raw speed. And speaking of speed, that's the perfect segue to our next group of superpowers, the performance pack. These are the keywords you're going to reach for when you just need things to be efficient and useful. So let's meet our utility hero, static. The key thing to get here is that a static method doesn't belong to a single object. It belongs to the class itself. What does that mean for you? It means you don't have to create a whole new object every time you want to use it. It's always there, ready for shared, common tasks. Think about something like a logger. You never want to create a new logger every single time you write a message. That would be crazy. You just want to call logger.log. And the performance? Ugh, it's blazing fast. No object to create, no virtual lookups, just pure speed. Okay, static is fast. We get it. But what if you need to go faster? Like, really faster? What if you're willing to bend the rules a little bit for that ultimate speed boost? Well, then you're ready to meet unsafe, the daredevil of C sharp. This keyword is literally your key to step outside of the .NET runtime safety net. It lets you work directly with memory pointers, just like you would in C++. It's incredibly powerful, but man, it comes with a massive warning label. I gotta be really clear here. You have to use this power wisely. It is absolutely essential for hyper-performance critical code. We're talking game engines, low-level graphics, that kind of stuff. But you are trading away the memory safety that makes .NET so great. One wrong move in an unsafe block, and you can cause some really nasty bugs. It is the definition of high risk, high reward. Phew, okay, let's step back from the edge and into the safe world again and talk about our final set of superpowers. These are the ones that help you build modern, scalable apps that can talk to the rest of the world.
First up is async. And honestly, this is the hero of almost every modern application you'll build. Paired with await, this is the magic that lets your app do long-running tasks like calling a web API or hitting a database without freezing the entire user interface. It is the key to keeping things feeling snappy and responsive.
And you will see async everywhere. Web APIs, database calls, reading files, basically any time your code has to wait for something else. Now, does it have a cost? Yep. Behind the scenes, the compiler builds this whole state machine, which adds a bit of overhead. But is it worth it? Absolutely. That small cost buys you incredible scalability and responsiveness.
All right, next up we have extern, which I like to call the world bridger. This is your superpower for talking to the world outside of .NET. When you absolutely need to call a function in an old C++ library or a low-level Windows API, extern is the keyword that builds that bridge for you. This is awesome for when you need to tap into platform-specific stuff or leverage some battle-tested legacy code. Performance-wise, the call itself can be super fast, but you do have to watch out for something called marshalling. That's the process of converting data types between the .NET world and the native world, and it can sometimes add a little overhead. And last but not least, we've got a really cool organizational power, partial. Think of it like a pie splitter. It lets you take the definition of a single class and chop it up across multiple different files, which can make huge classes way more manageable. The number one reason you'll use this is to keep code that a tool generates, like from a UI designer, separate from the code you actually write. It keeps your projects so much cleaner. And the best part, and this is awesome, it has literally zero performance impact. It's all a compile time trick. If a partial method doesn't have an implementation, the compiler just pretends the call was never there. It's free. And there you have it. That's the tour. From the deep flexibility of virtual and override to the absolute raw speed of static and unsafe, and the modern power of async. When you really master these keywords, you're not just writing code anymore, you're supercharging it. At the end of the day, each keyword is a power tool. It's a specific superpower for a specific job. And understanding the trade-offs, flexibility versus performance, safety versus speed, is what will make you a truly great architect. So the real question is, now that you've seen the arsenal, what are you going to build with it?